Hello, we are Group 345, and our topic will focus on integrated CCUS and green hydrogen strategy for sustainable biofuel production. The chosen theme of this project will be on the carbon capture utilization and hydrogen, CCUS, and more specifically, the innovation for this process as well as its focus on sustainability and choosing a greener approach. Now, why is CCUS important? First of all, it plays a major role for CO2 reduction. International Energy Agency predicts CCUS will be responsible for 15% of global CO2 reductions by 2050. Second of all, it's indispensable to industry in the sense that it's highly improbable for heavy industry and fossil fuel power plants to fully decarbonize without the implementation of CCUS. Next of all, blue hydrogen. The hydrogen produced from incorporating CCUS is much cheaper and easier to scale up compared to green hydrogen produced from completely renewable resources. And the next is measurable in the sense that it offers a more direct and verifiable method of reducing carbon emissions, and it also mitigates methane emissions, as it avoids flaring and venting of CO2-rich natural gas. What approach did we use for this project? In regards to carbon capture and storage, microalgae sequestration was applied, in which Chlorella vulgaris absorbs CO2 to produce biomass. And in terms of utilization, acid hydrolysis was applied on the microalgae biomass to produce sugar stream, which is fermented using microorganism Saccharomyces cerevisiae, and this follows the separate hydrolysis acid fermentation method, or HHF. Next, for the hydrogen part, electrolysis was conducted on water to produce hydrogen, and then paired with CO2 stream, it undergoes Fischer-Tropsch synthesis to produce monomer units which will produce polymer. In terms of cost analysis, the annual production cost is for 200 tons of bioethanol is found to be 89,800 USD. And the total equipment cost is approximated to be $2.2 million. Now, using simple calculation and taking into account that we have a 20,174 tons per year production rate of bioethanol, the total production cost was found to be $10.4 million per year. Now, market assessments, we have found that the selling price of bioethanol from microalgae was estimated to be $50.3 per kilogram. And with our production rate of 20.174 tons per year, the revenue could reach $1.01 billion a year. And the two main viable revenue methods is one, direct bioethanol sales to fuel distributors with gasoline or aviation fuel, or number two, export to regions with high ethanol demand but limited
The
production
process
capacity.
starts with the CCUS section, where exhaust gas is directed to an absorber using calcium oxide as the absorbent. Clean air and solids are separated and then enter a regenerator, where CaCO3 undergoes calcination, in which it is reverted to calcium oxide. Since the process has a 66% conversion, a recycle stream is used to maintain process efficiency. The captured CO2 is then directed to the water shift reactor and microalgae farm. Second part of the process, biomass is converted into ethanol using the algae block to simulate acid hydrolysis and fermentation. After separation, chlorine is produced from the acid hydrolysis, is absorbed using NaOH. Afterward, distillation columns are used to increase the purity of the ethanol up to 94.1%. The leftover water is then directed to an electrolyzer, which produces hydrogen. The hydrogen is then separated into two streams to satisfy the water shift reaction and FTS processes. Calculator blocks are used as a feedback controller, where it is controlling the makeup CEO amount, fraction of CO2 going to the water shift reactor, and flow of NaOH to neutralize the chlorine. About compatibility, scalability, and potential for flops. CCUS technologies are still developing with limited full-scale implementation. Challenges include the efficiency of CO2 capture, the high energy penalty of the capture process, and ensuring the scalability of capture system to reduce costs over time. The significant capital investment required for CCUS and green hydrogen projects can be a deterrent. Additionally, the absence of a formal carbon pricing mechanism or supportive market framework can hinder economic viability. In biofuel production, feedstock variability can affect the efficiency and feasibility. Addressing challenges related to feedstock variability is crucial for compatibility. Both CCUS and hydrogen production processes are energy intensive. For instance, integrating CCS into hydrogen production can increase energy consumption, affecting overall efficiency and operational
Now, to
costs.
summarize, the goal is to focus on an innovative and green approach to CCUS. The method will be carbon capture using microalgae, then applying HHF to produce biodiesel and FTS process to create monomer units to form polymer. The result is 2,304.48 kilograms per hour production rate of bioethanol and 0.22 kilograms per hour of olefin. And for economic analysis, to briefly summarize, we will make a $1 billion in profits.